Good morning. We all good? All right. Am I on? Is my mic on? All right. You never know. Sometimes you get feedback, sometimes you don't. So let's get rolling here. We are right at 9:30. Right time. So we just flew back from Michigan yesterday and Pennsylvania. We had 3 weeks on the road, so I'm happy to be back from vacation. Sometimes you're away too long, and it's good just to get back. All right, so this is getting to the core of .NET Core. My name is Adam Tuliper. I'm a principal software engineer with Microsoft living in sunny Southern California. One thing that I want to mention, I usually pack full my sessions with lots of information. And you know, from going to many sessions myself, I realize that you only take home maybe 20–30% of what you hear, if that, depending on how good you are with notes. So please download the slides for this presentation and the other ones that you attend. When you get back to work on Monday, whenever, open them up, run through them again. I include additional slides that you won't see during the presentation, and I have a lot of notes in there for you to kind of review. So it's an excellent way to kind of solidify what you've learned. I also have a slide in here, so if you see a couple things that I use and you're wondering like, hey, what tool is that? I have a slide in here that just lists a couple of tools. So this is not for the presentation now, just as a reference, this is in there if you want to check it out later. So I want to start out with a statement here. With .NET Core changes the way that you look at .NET. And granted, a lot of the same code works just fine, and there's a lot of similarities. But I feel that it changes the way that you look at efficiency. We've been used to the framework for a certain amount of time and kind of the baggage at times it has with it. And so you just kind of get used to things. But now, as you start using .NET Core and you look at maybe cross-platform or microservices and other architectures and performance, and .NET Standard is a term that you hear a lot surrounding not only .NET Core but other .NET platforms. We'll talk about that in a little bit. It kind of starts to change the way you think about .NET and .NET Core. As I mentioned, I'm Adam Tuliper. My contact info is up here. I'm available at any time. So if you have any questions, feel free to email me. If there's a question I can't get to at the end, or you wake up at 3 in the morning and you have a question about .NET Core, relationship advice, whatever, just shoot me off an email. I'm always available. These are the guys that keep me busy. Speaking of being up at night, because I might be up at 2 at night trying to catch up on everything after dealing with these guys during the day. I have 3 beautiful children, and that's my joy in life. Before we get started, docs.microsoft.com. We've gone through a major revolution at Microsoft with our documentation, and everything we're going to talk about today and more you can find on docs.microsoft.com. So if you have a question, that's the new home. You don't have to think about, well, where on MSDN did I see this? Everything, docs.microsoft.com. Click on .NET. You'll see .NET Framework, .NET Core. You can dive into as much really good documentation up there. That's been a huge push behind the scenes at Microsoft. So docs.microsoft.com. What are we going to cover today? What and why should you look at .NET Core? Where are we now? Kind of what bits have been released? Some of the binary details surrounding the platform. Platform differences. What happens when you run on Windows versus Linux versus OS X? Is it all the same stuff? What some of the differences are there and why? Command line and the tools extensibility. What happens if you do .NET space foo at the command line? What's the .NET standard? Although it's not, the .NET standard is its own concept, but it applies to .NET Framework, it applies to Xamarin, it applies to .NET Core. So it's very, very important to understand, especially since version 2 has just been official and released. And then we're going to look at deployments and publishing, and also how that kind of equates to the platform differences that we'll talk about too. So a lot of content. Take note, all of the application types that we're going to talk about here are really console apps, if you want to think about it that way. We're going to look at the command line. I'll show a little bit in Visual Studio. We have a lot of slides too, but just note that File, New Project in Visual Studio works just fine. We're going to dive into some deeper details. So yeah, we're going to kind of brush a little bit on the surface, but hopefully we'll uncover some things behind the scenes, how things work. So if you're looking at how to use .NET or how to write C# code, this is not the session. We're going to kind of look at really kind of the meat of all these concepts in .NET Core. But also, being that it's a .NET platform, a lot of the same things work the same. You can go in and write kind of your standard C#, C#7, C#6, whichever version you like to write for, it'll work on .NET Core. What is .NET Core? It is a .NET platform. And there's a handful of .NET platforms. You've got Mono, Xamarin, .NET Framework, .NET Core. These are examples of .NET platforms. They're kind of these freestanding stacks that you write for and you compile for a particular platform. General purpose, modular, cross-platform, and open source implementation of .NET. Some of the major components we'll touch upon: Core CLR, Core FX, and we'll see this image again in just a little bit. There's one thing I don't mention on here yet, and that's .NET.exe, and that kind of pulls everything together. When you think about a .NET Core application, these behind-the-scenes components that are provided for you are Core CLR and Core FX. Again, we'll dive into some more details on these. What's the full .NET framework? So yes, this is a .NET Core session, but what is a .NET framework? So it's a framework that's installed system-wide, exists on virtually any Windows PC that's out there on the planet nowadays, unless you have, like, I don't know, a really, really, really old one. I have coworkers that love the old Ataris and Nintendos, so won't be there. But it's installed system-wide, has a CLR, base class library, JIT compiler, and it kind of was installed in maybe these folders, maybe not. Now this is the time where I like to play this little video, how to determine where the .NET framework is installed and which version on your system. And so while this runs, just notice the amount of content here. I like to do bad tech jokes, because tech jokes are really, really, really hard. So these are all groaners. But while we look at that, what do you call two hobbits? Hobbite. I would tell you a UDP joke, but you might not get it. Anybody hear that one before? Who's ever done network programming? Those are the people that got the joke. One of my favorite ones is two SQL queries walk into a bar. They go up to a table and say, "May I join you?" You can always tell where, like, the database folks are, web programmers. All right, now I think we're just getting done with that. That was just on determining what version of the .NET framework is installed in the system. So you might think, oh, I could just check this folder, but that wasn't always true. A little bit difficult. So why are we throwing another platform at you? Supporting more .NET platforms is indeed challenging. Speed, full .NET framework had a lot of baggage with it. One of the little known, I think, facts about .NET Core is, according to the Tech and Power benchmarks, depending on which benchmark you look at, because there's a whole different ones they run, it's about 8 times faster than Node, 3 times faster than Go. So it's an incredibly fast framework, which is good. It's good to be in that list, top 10 list. Supports side-by-side deployment, we're going to look at later, but really how you can truly take multiple versions of an application and deploy them without an issue, without having to worry about corporate IT installing another patch on the system for .NET Framework or something like that. Cross-platform, command line first. Work on the command line and then make all the other tools work on top of that, including Visual Studio. So there's no black box. Here's a big one that I get. It's the .NET Framework going away. No, it's not. Really, it's 100% integrated into our tools, to our ecosystem, to everything. If you have Windows-only workloads and they work just fine for you, cool, keep it. Enough people have asked me this that I feel it's important to put up there. WinForms will not be coming to .NET Core. That is not the purpose of it. Well, when should we use this .NET Core? And this is directly taken out of our docs.microsoft.com. You have cross-platform needs, targeting microservices. You're doing something like Docker containers. High performance and scalable. .NET Core is extremely fast. And you need side-by-side versions. And the side-by-side versioning, to me, is actually reason enough alone after being in the enterprise for decades for me to choose .NET Core. We're going to talk about that versioning. Well, if you're running .NET Framework, when should you use that? Should you still keep it? Hey, that slide didn't show up right. If you have your Windows-only workloads currently, and they are working just fine for you, or you have NuGet packages that rely on Windows-specific libraries that might not work on .NET Core, those are times that you would consider to use full .NET Framework. If you have large installed applications, and you have no really pressing reason to port them, continue using. That works just fine. There's a session I have tomorrow on migrating to ASP.NET Core. Surrounding .NET Core, that's one of the big questions that you hear. Hey, should I migrate my application? And in the session tomorrow, we talk about that a little bit more. When should you migrate? Is it worth it? Is it something you should take part in? And there's a lot of questions that you need to ask yourself before you do that. Now, when you go into download .NET Core, you'll see 2 different ways of downloading it. You have the SDK and you have the runtime. The runtime is assuming that you have already this compiled application and you're going to go and throw it on a server somewhere that does not have any of the command line tools for it. In other words, you're not going to be building it. So for your laptops, for your machines, install the SDK because that gives you all the command line tools. So it has the runtime and the command line tooling to work with it. That's the SDK. Runtime does not have the command line tooling. Compilers. OK, so here's a couple terms let's clarify. .NET Core, standalone cross-platform framework with a runtime. .NET Core SDK installs the above item, .NET Core, that runtime. and the command line tools to work with it. What's ASP.NET Core? That's a web framework. It's a separate freestanding web framework that can run on either .NET Core or the full .NET framework, which are two .NET platforms. So where are we now? In production, this is exciting because we just released this. .NET Core SDK 2.0 is now official and released, which is awesome because that brings really so many more new APIs to .NET Core, which means lots more compatibility with existing full .NET Framework code that you might want to bring over to .NET Core. ASP.NET Core 2.0 has also been released as well. And what's in preview right now, the tooling in Visual Studio to work with 2.0 is in Visual Studio 15.3 Preview 3. I know, numbers and names. And Visual Studio 15, is that 2015? Well, no, it's 2017. Numbers and version numbers don't quite line up. So again, that has the tools to understand .NET Core 2.0, .NET Standard, but you still must also install .NET Core 2.0 separately. This I took from Scott Hunter and Scott Hanselman's talk from, I believe it was Build this year, because I think it's an important slide to show how is .NET Core doing in the developer community. On the left-hand side, this is Stack Overflow's surveys that they run. And number 3 most loved technology is .NET Core. I don't have the dreaded on there. I think in one of my other talks I do dreaded. And the number one dreaded language, any idea what it is? What was that? Visual Basic. I don't know why, though. Most popular languages by occupation, web developer, number 3 is C#. JavaScript, I think that's an obvious one. SQL, some debate if it's a language, and C#'s up there. All right, creating new. How do you use the command line to create a new? I used to show 1 and 2, but since 2.0 is final, let's just look at 2. We're going to do this at the command line too. So it's .NET new. And now with 2.0, you can specify the type of application you want to create. So .NET new console, then .NET run. Or if you want to do it separately, .NET new, .NET build creates your assembly for you, and then .NET whatever your assembly name is, and that runs it. For me, my workflow is I always do .NET new, and then I do .NET run, because that builds it and runs it for you. But you can also customize the command line a little bit more. And there's a post out there with all these different things you can set at the command line. If you have a particular use case, maybe you want to measure timings of the command line. You want to see how things are running. You can set parameters like this, .NET CLI capture timing. And you'll get percentages and times written out in the command line window for how things are running and compiling, how long the tool chain takes to run. There are data points that are collected at the command line, which are shared openly. You know, what commands on which platforms run the most. And all that information is open. We provide that. It's open source, open information. That's essentially the telemetry that the .NET command line collects. Visual Studio works just fine. Again, we're going to look at both, but just so you know, file new project in Visual Studio works absolutely fine for this as well. Now let's look at the command line here. Let's try. Let's make directory vs live. I'm here now, and I'm happy to be here after 3 weeks of on-the-road travel. Vacation, family vacation, 3 weeks of on-the-road travel. See. .NET new. Let's see what happens. So we see all these different template types that we can run here. Console, class lib, web, MVC, Razor, Angular. Now, the ones that you see here were like Angular, React, React Redux. These are additional tools that I've installed the command line, additional templates. So you can install additional templates that extend the .NET CLI. And so now, after I've installed these templates, it says, OK, I see these are new ones that you can create at the command line. Let's just keep it simple, though. Let's do .NET new console. One of the changes that just happened in .NET Core 2.0 is rather than having to do a .NET restore, which basically restores all your NuGet packages, any of the commands now that require .NET restore or implicitly or should require .NET restore, it just runs behind the scenes for you automatically now, which is kind of nice. .NET run. Hello world. Now let's actually add on. I'm going to add on one of my little command line parameters here. let's set our .NET CLI capture time equal to 1. Let's actually back up one step. There we go. So notice you get different percentages listed out here in everything that happens. So performance summary. So again, from the command line, you can add additional compilation options. But what was created here in everything I did? It was pretty simple. We have a program.c#, and let's do this. There's our C# project now. So much easier. Yes, we had a project.json and went through some refactoring to go back to a C# project file format, but it's so much simpler now. This is it. This is the C# project file. It says, hey, what are we targeting here? .NET Core 2.0 application. That's it. Super easy. What else was in here? Program.c#, console.writeline. Now our output, we're going to examine a little bit more. Let me just show you it briefly. DLL, our program debug database, and some other files we're going to talk about in a little bit. Similar things that you've been used to seeing if you've done any .NET framework compilation up to this point in time. All right, so everything that we just ran at the command line, where's the bits? So this installs side by side by default. We'll explore these folders in a moment. Let's talk about where everything is. It's a convention-driven layout. So everything that you need is at program files, .NET, and then a subfolder inside of there. And the main things that you'll want to look for typically are the SDK folder. Remember, the SDK is like the command line tooling. And shared, which really is the runtime that gets installed. So each version gets its own subdirectory. So if you install a new SDK, you get another subdirectory. If you install a new runtime, you get something else that shows up in your shared folder. The exception here is .NET.exe. .NET.exe is the driver. It's the command that runs everything for you, essentially. So that's the host. It's a simple application. We're going to look at this in a little bit more detail in a bit. Now, let's take the side-by-side installation. What does that mean? If we look at program files, .NET SDK, again, you can see all the different versions that I've installed on my system there. Each one just happily gets installed side by side. Visual Studio picks up on the latest one by default that you have installed. If you want to use a different version, then in your folder, you specify global.json, and you say, I want to use this target framework version instead, and it applies to everything underneath that subfolder. Otherwise, Visual Studio chooses the latest installed version on your system. Now, I mentioned this .NET binary that gets updated in place, and there's only one that's really active at one point in time. In other words, if I go to the command line, I type .NET, where is this guy located? Program files, .NET, .NET.exe. And that can get updated in place. All right, so let's look at C program files, .NET, SDK, shared, .NET.exe. It's all simple. So if I go to command line, oopsie. Where's .NET? There's only one that's active right now. Program files, .NET, .NET.exe, this one right here. Now I've installed all these different SDKs. You see them in here. Let's look at 2.0. So you see things like, C#, the targets file, all the DLLs, all the builds in here. So when you're doing all your command line build, all the stuff you find in your SDK folder. Again, the command line tooling to work with .NET Core. Your shared folder, I've installed 2.0. So all the binaries that represent .NET Core 2.0. Like, for example, if I want to do system.link, all those binaries, where is that? Right? Remember years back, the full .NET framework could go into like the global assembly cache, C/Windows/assembly, and it had that integrated shell handle that had a special looking window that was hard to get around, and sometimes you had to go to command line and fiddle with it. That's no more. Everything's here in the folder. So system.link, systemnet HTTP, all these libraries that are distributed as part of .NET Core live in the versions folder for your application. That's it. The layout is extremely simple. Program files, .NET. All right, let's talk about some binary details here. What makes up this application? We did .NET new to command line, .NET new console, and we ran this. So really, what's made up in that application? Well, we ran .NET.exe. That's the host. It's called the driver, or some folks internally call it the muxer, the multiplexer. That's the app host. That literally runs everything. .NET.exe, if you're using .NET Core, you will be using that everywhere. There is no my own custom app.exe with a big asterisk after that statement. Because if you deploy, which we're going to do later on, a self-contained deployment, you'll see, you won't find .NET.exe. You'll see my application name.exe, just like you would do currently, right? If you deploy an executable currently in the full .NET framework, you have my application.exe. You'll see that if you do a folder-based self-contained deployment in .NET Core, but it's really using a renamed .NET.exe behind the scenes. We'll talk about that in a bit. I just want to make sure I mention .NET.exe because it's a big part of everything. All right, so let's talk about Core CLR. Do you have to know what's in Core CLR? No, it's just understanding what's behind the scenes here. It's one of the repositories that you'll find up on GitHub. Core CLR is the runtime. That really is the meat behind the scenes of your app. That has all the base data types, int, all the base core libraries. Garbage collector, just-in-time compiler. So Core CLR in Windows, you'll find .NET.exe. Again, that's called the driver, and there's only one that matters. We looked at it at the command line. I didn't have to be in any particular folder. I could just type .NET wherever. It's in my path. It just works. Now, .NET.exe loads and starts Core CLR. So essentially, .NET.exe is the host for your application. It loads Core CLR, the runtime, and then there's also MS Core Lib. There's a lot of other important libraries behind the scenes, but really, MS Core Lib has these managed data types behind the scenes. All these, like a definition of an int, long, all these basic data types. And some of these libraries do interesting forwarding. They have a front-facing library that in turn forwards to other places. You'll see netstandard.dll is an example of this. You load it up and you look at it in something like .peak or ILDASM, and you find they do these type forwardings. So if I look for if I look here for an int, this is in MS Core Lib, it says, yeah, I don't actually have the definition. It exists somewhere else in one of my reference libraries. You have these central points that can be deployed on a platform that then forward to the other implementations. So .NET.exe loads the Core CLR. All of that is this runtime folder that we looked at, not the SDK folder. You'll find all these bits under the shared folder. So really, the takeaway from today, remember, SDK folder, shared folder. Shared folder is your runtime. Now, CoreFX. CoreFX is also a repository up on GitHub. CoreFX has the rest of the framework assemblies. So look at like system.runtime. If you want reflection, system.reflection. Things that really are additions. It's not the just-in-time compiler. It's not the garbage collector. It's the other libraries that you would likely use. System.link. Now this slide here tells you there's 60+ platform agnostic. What does that mean? They don't touch the operating system. It's basically code that has nothing that's operating system specific in there. This will make a little bit more sense when we look at the Windows versus Linux slides. There are libraries that have Windows-only implementations. You'll find kind of stubs or platform not supported exceptions raised on other platforms like Linux. Linux doesn't have a registry. So would you expect the registry APIs to work there? No, because there's no registry on Linux. So we do have some Windows-only functionality in some of the libraries. And then there are 30+ libraries that have platform-specific builds to them. So let's take the first one mentioned down here, system.console. It's a good example. When you look at a console on Linux and you look at a console on Windows, would you expect to write the same code from a lower level that integrates with them? No. Right? They're completely different operating systems. And so the .NET Core libraries have to take those platform considerations into consideration when they compile them. And so there are platform-specific compilations for Linux, platform-specific compilations for Windows. They're compiled separately. Here's a Linux version, here's a Windows version, because they need to interact with the operating system, and they do so in different ways. CoreFX has a ton of shared code, though. Why is that a good thing? Because as much code as you can share cross-platform, I believe the less instances of bugs that you can introduce, you have fewer platform differences. And in CoreFX, remember all those other libraries, link, system.link, etc., you have over 90% of code that's shared between them. Just to give you an example, system.console has 1,000 lines of shared code, 491 specific for Windows, and when it's compiled, just about 1,000 lines that are specific for Linux, and you can see some other examples up there as well. So we do take those platform specific considerations into account when we compile for them. All that is open source. Okay, now let's talk about the .NET EXE being this driver for your application. It hosts everything. And so if I come to a command line, and let's do .NET new MVC. Creates the template, does the restore, so it's pulling down the NuGet packages. Carrier pigeons leave the building. They come back, there we go. .NET run. While that's running, let's load up one of the greatest tools of all time, Process Explorer. All right, my web app is running. Let's go to Process Explorer and let's look for .NET.exe. I'll zoom in on this in a minute once I find what I'm looking for. Okay. Now here, I just created the app VS Live Web, so we can see that folder right there. I did a .NET run, which built the application and runs it for me. So it does two commands behind the scenes. So I get my bin debug folder, just like you would see in a .NET app currently. Now we have this .NET Core App 2.0 name that appears there, because it's a .NET Core app. So it's creating our output in a subfolder called .NET Core App. And we have VS Live web.dll. So there's a DLL, that's the output. Okay, what happens then? .NET.exe, .NET. That is the host for it. And that's important because even if you run this inside of IIS, for example, if you're doing ASP.NET Core, the same thing happens behind the scenes. You will see your application being hosted under .NET. So IIS talks to .NET.exe. In fact, the only web.config that you'll find there is just basically a definition that tells IIS how to use a platform handler to talk to this executable. Doesn't matter what platform you're running on, same principle. .NET.exe is the host, something else is going to proxy traffic to it. But that's it. So it doesn't matter if you're writing a whatever kind, microservice, some sort of web app, it doesn't matter. Everything is hosted in this .NET.exe. So a web app is, for all intents and purposes, a console app. You don't have to interact with the console. You don't have to ever specify that, right? You can just install it in IIS or however you want to run it, and it just runs. But technically, you can go to the command line and run it as a console app. Okay, some platform differences. Why might we have platform differences? Because we talked about console, for example. Some features do absolutely require native code. Security is a great example of that. On Windows, we know exactly at Microsoft what gets released with a version of Windows, right? We kind of know what our, quote, distribution is, so to say. It's predetermined, and we know what gets released with the end versions, professional, whatever versions that we spin. Now on Linux, it's a different model. There's no guarantee on what's there. There's just different distributions. Folks customize it all the time. Certain libraries may or may not be there. And so that creates an interesting challenge. It creates a little bit more knowledge when you have to create your application to run on something like Linux, because you must know maybe what underlying features that you need. And if it's not there, it might not fail until your application requests that particular feature. Apple on OS X or Mac OS, they replaced OpenSSL. If you guys remember the whole bug a couple of years back, the vulnerability found in SSL, that was a big one. So OpenSSL, Apple replaced with their own Apple cryptolibs. So all these different platform-specific things that you have to be aware of. So let's talk about Windows first. This high-level view. The ones in green are the things that don't care about what platform you're running on. It's the same C# code that gets compiled for Linux, Mac OS, and Windows. System.link is a great example. Doesn't care about the operating system. Now, the yellow ones here are platform-specific implementations. System.console. We have to integrate with a different console on Linux than we do on Windows. So there's platform-specific code there. Now, on Windows, we have our operating system level, and we know exactly what libraries are there. That's our, quote, distribution, so to say. Let's look at Unix, Linux. Same thing. We have these platform-agnostic libraries, top level. Next level down, system.console. Again, platform-specific compilation. Now, the next level down, on Linux we have these SO, these shared objects. Think of them as like DLLs. And so all these libraries, you'll find like system.native. These shared objects, .NET Core, these DLLs, will communicate down through these shared object libraries. Again, think of them as DLLs. Who in turn communicate down to SO files on Linux that may or may not be there. So like libcrypto, libssl, these ones over here. So this is really the top down, going to this bottom level. And so just keep in mind that if you try something and maybe you're doing SSL and you get some strange message, go back and read the documentation. It says, oh, you're running this on Linux. You might need to make sure that you run apt-get some library name, some package name, so you install those binaries onto your system. Usually that's pretty well documented up on docs.microsoft.com, but it is important to understand the difference that when you go on Windows, we understand what a distribution is. Those libraries are there. When you switch over to Unix, you might just have to be Linux. You might have to be aware of what libraries might be missing, and so you might have to pull them in, make sure that they're in your particular scripts to build up your environment, or make sure you're getting the right Docker container that has them already installed. All right, now speaking of Linux, this is interesting to me here. I want to see what's the difference if I run this on Linux. How is this laid out on Linux? So what I've done is we have a newly released .NET SDK, .NET Core 2.0 SDK that you can find up on Docker. So if you've never used Docker before, who's using Docker now? All right, so about 7 of you or so. All right, Docker, I believe, is one of the things that can completely simplify your workflow. It's a really amazing technology. It works on Linux, works on Windows. You can run Linux containers on Windows. You can run Windows containers on Windows. It sits in this middle ground between fully running as an executable on your operating system and a VM, although it's not a VM by any means. But it's instant on, runs in the context of your current running operating system, shares libraries with it. So you notice I installed right here this container, .NET 2.0. And it's already on my system. If not, I would pull it down. And instantly, I'm running this. I'm at a Linux command line. This is an image that we provide at Microsoft. I can say .NET version 2.0. Which .NET, it's in user bin.net, cd user bin.net. Oops, user bin, sorry about that, because .NET is an alias. You can see that .NET says, oh, we're going to point over to this user share .NET folder. cd user share .NET. All right. Notice we have SDK folder. We have a shared folder. Let's see what's in the cd shared. Microsoft.NET Core.app. Well, that's interesting because on my system, program files.net, under my shared folder, I too have a Microsoft.NET Core.app. If I go into there, I see the version and all my libraries. And so over on Linux, same thing. Same thing. But you notice, now you'll find some of the other files that we talked about, these shared objects. Yes, we still have the DLLs for the pure .NET Core code, which at some level, some of them communicate with these shared objects, which in turn communicate with some of the operating system shared objects. So all in all, the same thing works. I can do a make directory vs live, cd vs live, .NET new MVC. Same exact thing, right? My output is going to be no different. There we have all our folders, all our files, .NET run. Give it a second here, and we are running in a Linux container, and my application will start up, run on port 5000. All the same output, doesn't matter if you're running it on Windows or Linux. Takeaway there is it's the same. A couple different files installed in the SDK, but really the experience is the exact same on the command line. Which brings us to another question here. When they developed the command line, or which came first? Several principles. .NET Core is command line first. Let's make sure that the command line works first, and then we can throw the other tools on top of it. Whatever tooling you want to use, Visual Studio or anything else, doesn't matter. Now the driver, .NET.exe, or just .NET if you're on Linux, knows enough to run the commands that you specify and no more. And all these commands are consumable by humans and machines. What does that mean? It means that either you can go in and type it, or a tool can go in and use that command as well, like Visual Studio or whatever your IDE is. Now those commands, we call them verbs. So there's .NET, the driver, .NET.exe, and run is the verb. Verbs are implemented in a few different ways. Either a NuGet package that gets pulled in and it understands, or a binary, some sort of executable in your path. So .NET my custom build script, or .NET foo. It's really just another way that .NET can help you extend your application. .NET.exe itself is really a fairly basic application. The source code to this console app, .NET.exe is a console app. You can see it right up on GitHub. That's it. That's all of .NET.exe. Not a very huge program. There's a couple commands it understands out of the box. Anything else is by something that exists either in your current path, like a NuGet package, or some other script. Driver invokes the command, like .NET foo or .NET run. There's some library that understands what that command is, and then any additional command line parameters, it passes to it. .NET.exe doesn't do anything but say, all right, who's going to run this? You are. Here's the command line parameters. Everything goes through .NET.exe. So .NET, that is the driver. Whatever your command there, that's the verb. And those parameters get passed to whoever's going to handle that verb. Out of the box, you get a handful of them. .NET new, restore, run, build, publish, pack, test. Up until a few days ago, actually, .NET Restore you'd have to run manually, but as I mentioned earlier, .NET Restore is handled out of the box in 2.0 for you in most of the cases that need it. You don't have to worry about that anymore. If we do a .NET build, what do we get? Now remember that a .NET run does a build and then runs it for you. So .NET build or .NET run is going to create your output. And we get our DLL and PDB. So our DLL is your application. PDB is, of course, your program debug database. That's what allows your debugger to work with it. Gives you simple information. It maps your line numbers. You know, when you're debugging your source code, how does it know that this line of source code matches what's in my binary? All that magic is kept in your PDB file. Then you'll find this deps.json file in there. That tells the driver, .NET.exe, where to look for different dependencies for this application. If you want some good advice, don't touch it. Leave that file go. Now, if you like twiddling with things, runtime config.json, that's all yours. Go in there and you can change different things about the garbage collector. Kind of you can customize that information if you have a specific use case for it. Out of the box, there's no reason for you to go in and start doing that. But if you'd like to see how you can fine-tune things for your specific environments, that's a place you can check, runtime config.json. Completely optional to touch that file, though. All right, let's talk about one of my favorite subjects, the .NET standard. Who understands what the .NET standard is? Excellent. I didn't see a single hand. Make sure there's not one in the back that just ran out on me saying, I already know this, I'm not going to be here for this. All right. Yes, good. All right. I'm going to cover this today and the session tomorrow because honestly, if there's one takeaway that I want from any of my sessions, it's for somebody to have an idea of what .NET standard is. When I first started learning about it, I'm like, gosh, this seems so complicated. I don't understand it. What does it all mean? And then one day I realized it was so simple. I was making it so much more complicated in my brain than it really was. It's nothing more than a list of APIs a platform has to implement to be considered .NET standard compliant. That's it. There's a bunch of APIs. It says, all right, if you support these APIs, you are .NET standard 1.5 compliant. Okay, that's one thing. So it's a contract. You are compliant with net standard 1.5 or 2.0 or 1.9. What good does that do you? It means that you can compile a library for .NET standard. And you can take that library you've compiled for .NET standard, and I'll show you that in Visual Studio, what that looks like. You can take that library you've compiled for .NET standard and bring it to any platform that is 1.5 compliant or 2.0 compliant. There's a grid you can look at. Does this support .NET standard 2.0? It does. I can take my library and bring it to that platform. I can bring it to Xamarin. I can bring it to .NET Core. I can bring it to .NET Framework 4.6.1. And you can run it in there with confidence that it's going to run OK. It's a contract. That's it. So .NET Standard 2 was just released. Who does it run for? .NET Framework 4.6.1. Let me pause that 1 second. Again, this means if I take this block of paper here I'm holding up, this is a DLL I have just compiled, and I have said, this is, I'm going to compile this for .NET Standard 2.0. That's my representation of a DLL. And I've just told Visual Studio, compile this as .NET Standard 2.0. Who can I run this on? Well, I can run this on .NET Framework 4.6.1. I can take this DLL and include it in a .NET Core 2.0 project. I can include it in a Mono 5.4. I can include it in Xamarin iOS, Xamarin.Mac, Android. And later on this year, I can take the same library and include it in a UWP application. And my code will run just fine. That's what it means. It does mean some other things behind the scenes, like you can take a certain amount of .NET Framework code and run it on .NET Core. That's kind of some additional benefits. But out of the box, it means you can take this library you've compiled for .NET Standard, and you can run it across these platforms. So again, you can take your .NET Standard library and run it on all those platforms. It also means you can take a 4.6.1 class library and usually run it on these various environments. There's a big, I want to put a big asterisk after this statement. This is because of some kind of a goodness that they provided behind the scenes that allow you to take a lot of this code. They realized that on NuGet, something on the order of about, I think it was 70% of NuGet packages were .NET Standard. If they looked at the API service, about 70% of them were like .NET Standard compliant. I mean, you could take those and run a lot of them on any of these platforms that support .NET Core 2.0, for example, and it would run OK. So they've included some work behind the scenes in like the Visual Studio tooling, for example, to allow you to bring these references in. So if I take let's say in your environment, you're creating a new .NET Core application, and you have all these libraries, you know, your customer libraries, whatever, that you've compiled for .NET Framework. Can you bring them over? Because of some of the tooling that they've done here, yes, you can. With an asterisk, if you do things like reference WinForms libraries, it will fail when it tries to access that code. But if you don't do that, then your code will probably run OK. You'll get a warning in Visual Studio saying, hey, you're bringing in a 4.6.1 binary into a .NET Core 2.0 application. I'm going to show you this warning. Like, I'm allowing this. But in the future, you should probably recompile that library for .NET Standard just to make sure everything's good. So without .NET Standard, what happened? Oops, let's go back here. Without .NET Standard, you took a library, compiled, you were working on Xamarin, and you had a class library. And you couldn't really bring that over to your .NET Framework 4.6 application. You had this concept of portable class libraries, which if you've ever used them, I apologize on behalf of portable class library community. It was just a mess. You didn't specify that you were compliant to something. You really specified your target systems you were going to run on. Oh, I need to run this on Silverlight and Windows Phone, whatever. That was it. You couldn't take it anywhere else then. It was kind of the best we had at the time. We've changed that model now. With .NET Standard, you're not specifying your target platform. You're saying, I am compliant with this contract. And automatically, you can bring it to different platforms. So now, with .NET Standard, you compile your class library against .NET Standard. And you can now bring it across these different platforms. And there's a list of them that we saw before, right? Various Xamarin's, .NET Core, .NET Framework, UWP. So this really opens things up quite a bit. So if I take a library, and I have compiled this for .NET Standard 2.0. Again, we'll look at this in Visual Studio so you can see what the tooling looks like visually in a second. But if you compile this against 2.0 right here, take a DLL, compile against 2.0, who can I run? What projects can I include that DLL in? Well, I can include it in a .NET Core 2.0 app. I can include it in a .NET Framework 4.6.1 app, all down the line. And in the future, we might see other platforms show up there, because there are other .NET platforms as well. Unity, for example, even though they run on their kind of own version currently of Mono with some additional modifications on there, Unity is a huge community. I mean, brings millions of C# developers to the table. OK, let's talk about some references here. Meta package. We'll examine these two when we look. I'll show you what it looks like in Visual Studio, even though it has some screenshots here. A term that you'll see when talking about .NET Core is a meta package. It almost seems like it should be mega package. Meta package. A meta package is a name. And you'll see something like we've looked at before, like Microsoft.NET Core.app. In fact, if you remember, we saw that right here. Microsoft.NET Core.app. So you see a couple of these names that appear over and over again. Microsoft.NET Core.app is one of them. NetStandard.library, and Microsoft.ASP.NET Core.all. These are three very common ones that you'll see. All they mean is your project references that name, and it means it automatically includes a bunch of other references. So if you're creating an ASP.NET Core application, should you have to include the DLLs or the NuGet package for MVC? Should you have to include the NuGet packages for Entity Framework? It's a very common thing for folks to use, and so on down the line, right? When you want to write a web app, there's maybe 12 different common packages that are used all the time. Should you have to include all these little bits and pieces every single time in your app? That's one of the things that the ASP.NET Core team realized early on was package management was a bit of a pain for people. They had to include all these references over and over. Oh, I forgot this one. I had to include it. Oh, I forgot this one, had to include it. So the concept of a meta package is you reference the meta package and you automatically get a contained list of packages. Well, what happens if you only use functionality out of 2 of those packages? What happens when you deploy your application? Compiler's smart enough to only include what you need with that application. So if you create a .NET Standard library and you expand the references in Visual Studio, this is what you'll see. There's my class library. It's a .NET Standard class library. And if you look at the references, notice Visual Studio is smart enough to show you the difference between your NuGet packages you're referencing and kind of understanding what an SDK is here. It says, oh, OK, you're using a .NET Standard SDK, and you're referencing .NET Standard library. All my library cares about is one reference, .NET Standard library. And you get all of these packages out of the box that it understands. It just prevents you from having to add a bazillion NuGet references to your project. What I'm looking at right here is what you get out of the box. File, new project, .NET Standard class library. That's out of the box, you get that. But you'll see this .NET Standard library moniker, this meta package name, appear over and over. You'll also see .NET Core app. We've looked at that. We've looked at the folder. What do you get with that? All the stuff that is a .NET Core application. System.link, system.buffer, system.collections. Should you have to add all those references every time? Heck no. All right, so let's look at Visual Studio tooling here for creating a .NET Standard library and the Visual Studio projects. File, new project. I'm not going to create a new project here. I want to show you the options, and then we'll look at what I already have created here. But on the left-hand side, just take a note here. There's a specific item here for .NET Core. There is now a specific item for .NET Standard. Why would you use .NET Standard? Honestly, going forward, it's probably a good idea. If you have any inkling that you might ever use your code in different .NET platforms. If you might use it on the full .NET framework, and at some point in time you might use it on .NET Core, and or you might use it in UWP or Xamarin, you're adhering to this contract when you compile for .NET Standard. You don't have to. You can come in here and say, no, you know what? I just want to create a .NET Core class library. I'm never going to use this on any other platform. Or if you're using full .NET Framework for years, you go and you create a new class library. You can still do that. But you now have the option to create a .NET Standard library that you can now make portable between these different environments, these different platforms. All right, so .NET Core, we can create a console app, class library, ASP.NET Core application. We could do all that from the command line. I actually installed more command line templates. So technically, because I installed more command line templates, I have some more options with the command line. Although through the Visual Studio and the extensions gallery, you can always grab in new templates for Visual Studio here. For .NET Standard, what can I create? I get one item. I can only create a class library. And that makes sense, because all we are creating are these class libraries that we can bring between our different platforms. So let's see what these guys look like here. Let's explain this application. We have a .NET Core class library. Let me expand this a little bit. Grab my pen I dropped. So we have our main guy we're going to run here, a .NET Core console application. What SDK does it use? Notice it shows you. It's a Microsoft.NET Core.app meta package. What dependencies do we have? Any other projects that are in my solution here? And here, you can just focus on the .NET Framework 4.6.1 stuff. I have a .NET Standard class library, and I have a WPF app. Who is the portable guy in here? This one. I can take this .NET Standard class lib and include that as a reference in literally every single project that I have listed here without having to worry about it. I'm compiling it for .NET Standard. Well, what does that mean? How do you compile for .NET Standard? That's what it looks like. Your project properties. That's the drop-down. You say, I want to compile this for .NET Standard 2.0. Cool. When it compiles, it checks the APIs that you use against the known contract for .NET Standard 2.0. If you have something else in there that's not part of it, it will tell you. That makes this code portable between all my other projects. Now, if you look at so that's scenario number one. My .NET Standard library, I can take across all these other projects. Scenario number two, probably quite likely for a lot of you in this room, you have existing .NET Framework 4.6.1 code. And maybe you want to bring that over to .NET Core. Can you do that? Well, that's what I've done here. If you look at my Core console app, I've included a reference to this. I can also bring in a .NET 4.6.1 NuGet package into my .NET Core application. I would get a warning, which is by design. They want to tell you for every NuGet package that you bring in that's 4.6.1 compliant, for every single one, it's going to give you a warning for it. In this case, I just added a project reference. And it works. In fact, let's go into my source code here, program that C#. Console.write line, and I'm going into my .NET 4.6.1 class library. Step into that. And now this is an interesting one I wanted to do specifically, because if you notice, this code, from my .NET Core application, I've gone into my .NET Framework class library, and it works. And I'm also calling an app, something that does an app domain here. This used to not work, because app domains were not supported in .NET Core. That was like a full .NET Framework model, right? Something else could spin up this new app domain and host multiple domains. That concept does not exist in .NET Core. However, there's a lot of code in 4.6.1 that uses app domains, sometimes to register things on startup. And so they've brought a minimalistic view of an app domain to .NET Standard. It's not the full implementation that you would find on .NET 4.6.1, but it's enough to cover most of the use cases. And so this code actually works just fine. I can get my domain calling name, core console app, return it. Now I'm back into my .NET Core application. Now, if I was in my .NET Framework class library to reference something in WinForms, when I run this, it would blow up. Unable to find, I don't know, whatever WinForms library I happen to be using. So your code can come over. There's no necessary guarantee that it'll run. If you know that your code is pretty .NET Standard compliant, in other words, you're using really just all the APIs defined in .NET Standard, that should work OK. You can kind of get an idea, too, for if we look in, let's look at, on our documentation, let's look at netstandard.library. So we have a page out there that describes these meta packages, the same ones we've just talked about. If I look at the netstandard.library meta package, notice we get redirected over to NuGet, and we can see really what we have. Let's go. We're on 2.0. This essentially right here, this is the contract of what is supported inside of there. If we go over to our actual application here, and we look at our net standard class lib, and we expand it, you can see everything that's included in net standard library. We don't have to worry about including those as manual references, but all the APIs that net standard, let's say 2.0 or whatever we've targeted this library for, are all listed right here. So it's another view that we have inside of Visual Studio now. If we change our library version here, net standard 2.0, and we go ahead and build, there we go. Wait for that restore to finish. Or my restore bonked out for some reason. There we go. Yeah, now the restore finished. Why did we see a little, if you caught it, why did we see a little exclamation point that showed up here? Because I just went from 1.6 to 2.0, so it had to pull down or check locally to make sure I had all of those 2.0 packages installed. That's what it was doing. And when it finished doing those verifications or pulling it down, the app continued to compile and everything worked. So that's it. Now it's a new option you have in Visual Studio to create a net standard library. You can take your 4.6.1 code and bring it over to your .NET Core applications, and it might work. Again, we saw like 70% of NuGet packages were pretty compliant out there. It's just one thing that you have to be aware of. You can bring it over, but make sure that your code is compliant. Now, how about publishing your applications? All right, we have a framework-dependent deployment, which is very similar to a deployment model you would do with .NET Framework currently. In other words, I'm taking my application, and I'm going to go throw it out on my production server, and I'm assuming that the framework is already installed there. That's what we've done with .NET Framework all the time, right? Since the beginning of time. It's installed on a server. That's a framework-dependent deployment. Same thing exists for .NET Core. It says, hey, I'm assuming that in program files.NET that you have the runtime already installed for 2.0. So I'm only going to give you a DLL, and you install it, and you run it. No problem. How do you run it? .NET assembly name. The other one, my favorite, self-contained deployment. This is way cool. Maybe it's because I was scarred by having many late nights. I was in enterprise for a couple decades, and gosh, the number of nights that we would have to go and be there when the systems went down and .NET patches and deploying applications. Oh, hey, you want to install the latest patch for .NET Framework on the system? Cool. We have to test all the web applications running out there first. Like, it was painful, and self-contained deployments take that pain away. So this takes everything your application needs to run and puts it into a folder. And by everything, I mean everything. I mean the runtime, the JIT compiler, everything. So I can take my application, and I can create this self-contained deployment, and I give you this folder, and you have a brand new computer. Has nothing installed on it. Like, you have a new Windows 10 computer or server, and you take this folder, and you go in and you launch the executable, and it just works. Everything is in that folder. Nothing needs to be installed in the system. Sure, your folder is a little bit bigger, but there's no dependencies on the system. And so all of your application deployments can now be folder-based. That's a self-contained deployment. We'll look at how you compile one or the other. In order to do a self-contained deployment, you specify a runtime identifier that you're going to publish. And we'll see them in a command line, but they look like these. Linux 64, Linux ARM. ARM is brand new as of 2.0. Win x64, Win x86, OS X, x64. These are called RIDs, runtime identifiers. And so when you specify you want a self-contained deployment, you're going to specify these runtime identifiers. Why? Because we looked at there's platform-specific libraries we have compiled. System.console, remember. Oops. System.console was compiled differently for Linux as it was for Windows. So when we're going to create your folder with everything we need in it, we need a different system.console. For Linux, different one for Windows. Same thing for executables, right? Executable on Windows is a particular, it's a PE, portable executable file format. Anybody know the first 2 bytes of any exe file? MZ. I believe it was the initials of the gentleman that created the file format. Open up any executable file format in an editor, you'll see MZ is the first 2 bytes in there. So that's Windows. It's not the same on Linux. Linux doesn't have an exe, right? It has an attribute that it's executable. So let's look at creating this here. I'm going to go ahead and let's close that, and we are going to run, we're going to do our x64 first. Okay, so let's go ahead and look at this folder. Bin, I'm going to delete everything in here. .NET build. Let's wait for it. There we go. We see a debug folder that shows up. And just like we saw on the slide earlier, we have NetCore app. We have our DLL and our PDB. That's a framework-dependent deployment. Now, I can run .NET Publish and create a release version of this. So I'm publishing. Publish is the way to create your production. This is like the guaranteed way to create your production deployment for it. You run .NET Publish. Again, you can do it through Visual Studio as well. So I'm going to come over here. Bin, I have a release folder now. Same thing. I've got my DLL and my PDB. That's my framework-dependent deployment. I'm expecting you to have that installed on the destination system. I will give you this folder, and it will just work. It's a glorious world. Now, let's take another scenario. I specifically want to create a Windows 10 compatible deployment. A self-contained deployment, meaning I don't care if you have anything installed or not. I want to give you this folder, and I just want it to work. So let's run this, and let's keep an eye on the output folder here. Okay. Now notice we now have a Win10-x64 folder. And we have, let me actually run a couple commands here because we're going to do, while that runs, we're going to look at the output for a couple of them. And let's run the Linux as well. Okay. So if we look at the output of this folder, I have my DLL and I have my PDB. What the heck is this guy? Why is there an exe file there? That's basically .NET.exe. Well, why is it called .NET.exe? Because imagine if you had 100 applications running on your server and they were all named .NET.exe and you needed to shut one of them down. That would be a real pain. So it's basically a renamed, in a sense, .NET.exe. It's your host application that launches everything and runs it. And we have everything that's required to kind of run this application. If we look, there's system.link. Everything is included that we need to run this application. Now, we've done our other ones here. So if you look at Linux, for example, Linux, we have our DLL, and we have our PDB. Here's our executable for Linux, right? It's an executable attribute. There's no vslive.exe. Notice we have some shared objects for Linux here. I can give you this You can bring that folder over to a Linux system and run it without the framework being installed on there. So that is our framework-dependent deployment. And they're extremely easy to do, right? We saw the command line. You run publish. You give it a runtime identifier. And voila, it just works. OK, so we looked at what and why .NET Core. Where are we now? We've got 2.0 released for .NET Core. We've got .NET Standard 2.0. And we have ASP.NET Core 2.0 released. Whew, it's a glorious world. We talked about some binary details and how we do kind of the platform compilations between them, what Core CLR, Core FX are. .NET Standard, simply a contract. You can compile against that contract, and now you know your code will work across all these different .NET platforms, about 5 of them currently. And we looked at deployments and essentially publishing and a runtime identifier. You need that runtime identifier to pull in the platform-specific code or make your platform-specific deployment. You know, we just saw that on Linux. We have VS Live, and on Windows, it's vslive.exe. I can't stress enough docs.microsoft.com. There is a ton of awesome information out there. That really, folks are going crazy inside of Microsoft, working on documentation. Many have it as their primary goal to make sure that is tip-top documentation. You can see, it's all up on GitHub. You can see the contributors on there. If you have any issues, sometimes you can, at least internally, I'll reach out to the folks and they'll be like, hey, I've got a question about XYZ. Not that I necessarily recommend that approach for everybody, but it's just nice to be able to see the names out there. If you have questions about .NET Core, everything is open source. If something doesn't seem to be working right, go file an issue on GitHub. That's the place for it. Everything is in the open. Which is great. You can see some of the discussions. I remember one comment about the .NET Core telemetry, what they collected the command line. And I remember, I'm paraphrasing, but it was something like, we can't do it that way because if we do it, the world will hate us. So everything is open. You can see these discussions, not only for .NET Core and ASP.NET Core and NetFramework.core, but things like the C# language specifications. Fascinating to go see all the new features they're proposing and how they're framing that. Hey, we're going to include local methods. In other words, you can have methods inside of C#7. And folks, well, can't we do this with lambdas currently? No, because XYZ. I can't stress that enough. It's a great place for learning. If you have any questions about today's session, by all means, reach out to me, adamT.microsoft.com. And thank you, guys. And I'll open up for questions now. Thank you. Yes?
One thing that I saw when you had the .NET new, one of the options was SLN. Does that mean you can create a Visual Studio compatible solution now?
.NET, let's see, you said the question was when we saw a SLN on there, let me see. I've never run the SLN to be, let's see, .NET new, let's try it, SLN. I wonder if that gives you just the let's see, oopsie. Let's make directory SLN, cd SLN, .NET new SLN, so I don't stop on my current project. Yeah, just gives you the solution file. Why do you get just a solution file? Probably just to have your basic config on there. I don't know. I've never run that option before. Interesting observation.
Well, what I was looking for was compatibility between the code tool on Linux and Visual Studio.
I'm not sure on that. Come talk to me afterwards. Maybe I can take a note and see if I can find an answer out for you. Yes, in the back there. I'm sorry, say that again? Like Windows Workflow Foundation? I'm not sure. I haven't touched Workflow Foundation in about 6 years. I would just have to go and search on that for the same way as you. And the first question was SOAP. I don't know, also because I haven't used SOAP in probably 8 years. I'm sorry I don't have a good answer for you there. For the folks that are using like WCF, I just saw there were some release notes because they had a compatibility shim that they released for doing WCF. And I saw, but I didn't read the release notes. There was a note on there on 2.0 for WCF as well, but I haven't read those. So I don't have a better answer for you on that. Yes?
I have a couple questions. The first is, I know there's a Visual Studio add-in that you can use to test for compliance. And I'm wondering, is there anything in command line so we could automate if we want to check like thousands of projects at once? Are they compliant with this thing or that one?
So the question is, there's an add-in for Visual Studio, and can you do anything in the command line? From the add-in for Visual Studio, I actually talk about this a bit during the session tomorrow for porting. I might have it listed on the end here. Give me one quick second here. I'm not sure if you can trigger this off of the command line or not. The other question about the compatibility is this. You can install the API compatibility analyzer, and the analyzer will run you through a project. You basically give it your DLL, and it will run through and determine the API compatibility in there. I don't know of a command line option for it. I don't know if they've extended this for the command line. I would probably have to go onto the project site and see if they have a way of referencing it to the command line. The other thing that you can do, which doesn't answer your second question, but is another approach too, you can go in for the API browser. So if you are looking at doing something, wondering if something's supported, like system.net.mail, for example, or system webmail, you can go in and search for a particular API on there and see if it's supported. And for the folks that I couldn't get your questions, if you guys want to come up at the end and give me your email addresses, I can find out answers. And I can make sure I get back to you on those as well. I don't want to just cut you off saying, sorry, I don't have a better answer for you. But if you come to me afterwards, I'll get your email and make sure to get you guys an answer. Yes?
Actually, my other question is about the self-contained installation. Are they planning on doing anything like that for framework, or is it?
I can't speak as to what they would or wouldn't do in the future. I've never heard that they would do that for framework, and I can't imagine. But that's purely speculation based on just how that is currently packaged up and distributed. And the work that's gone into .NET Core to enable that. I don't believe so. I would be shocked if so. But then again, when the HoloLens was released, I was like, what? Yes?
You said there's never going to be any WinForm support, but has there been considered supporting any other kind of UI? Strictly going to be
Not that I've heard or seen even in the use cases for it, or when you look at the documentation for when to use .NET Core, if you look at currently what's out there and supported, those are none of the recommended or even roadmap scenarios coming up. The roadmap for .NET Core is out there public as well. You can check that as well. Yes, question?
How does the performance of .NET Core compare between platforms?
It depends. So if you look at the Tech and Power benchmarks, the fastest benchmark that was accomplished on there was actually on ASP.NET Core on Linux. But I don't know if that was a result of the specific tests that they were running, because I believe all of their tests that they run for Tech and Power, I think, are all Linux-based. So that just might be an artifact of having to be able to run inside of that scenario. I had seen early on, and I haven't seen it in quite some time, early on that the Windows bits were faster than the Linux bits. That was a while ago. That was at least a year ago. And they were doing significant optimizations on there. In fact, as of the last Tech and Power benchmarks or two, they said that the ASP.NET Core was the fastest, the largest improvement in a framework that you've ever seen between iterations. So I'd like to say it's getting pretty on par, considering a lot of that is very similar now. But the Tech and Power benchmarks don't really give you a good, perfect understanding of that behind the scenes. All right, what are we at? We got time here? 1 more minute. Any other questions? Cool. Well, again, thank you very much. I'll hang around if any of you want to give me your email addresses for the other questions. And I have a session tomorrow morning, 8 o'clock, bright and early, on migrating to ASP.NET Core, a true story. And we'll see you guys later. Enjoy the rest of VS Live. Thanks.